In our final panel for today, we will hear from new fellows with experience in translating, collaborating, and commercializing research. This panel will be moderated by distinguished Professor Jagadish. Professor Jagadish is the president of the Australian Academy of Science. So if I can invite you, Professor Jagadish, to the stage. Joining Professor Jagadish are Professor Michael Bredmore, who's the director of the Australian Centre for Research on Separation Science at UTAS. Professor Bredmore is an outstanding analytical chemist. His lab on a chip technology separates complex mixtures of chemicals on miniature scale, enabling users to test samples and get results on the spot. Next, we have Kirsten Rose, who's the executive director of Future Industries at CSIRO. Kirsten is a respected leader in technology and innovation with a career spanning 30 years in the US, UK, and Australia. She's a member of CSIRO's executive team, overseeing a portfolio encompassing of over 2,000 research scientists and engineers and more than 500 million in annual research investment. Professor Madhu Bhaskaran, who's the co-leader of Functional Materials and Microsystems Research Group, joins us next from RMIT University. Professor Bhaskaran is an engineer who has developed stretchable skin-like electronic devices for better healthcare. As skin patches, the technology can monitor health parameters or include sensors measuring UV exposure for melanoma prevention. It can be integrated into mattresses for improved monitoring in aged care and intensive care for SIDS. Next, I'd like to invite Dr. Jack Steele. Jack is the Director of Science, Impact and Policy at CSIRO. Dr. Jack Steele has driven national initiatives to commercialize scientific research for decades. From 2015, he led the establishment of CSIRO's Main Sequence, an innovation fund commercializing deep technology public sector research. Next, I'd like to invite Professor Wei Zhang, who is the Research Director for Marine Bioproducts, CRC, and the Founding Director for the Center for Marine Bioproducts Development at Flinders University. Professor Zhang is an inspiring leader in marine biorefinery and bioproduct development technologies, and he has passionately pursued an overarching career driving translational research with industry impact. And last but not least, distinguished Professor Dietmar Hutmacher, who is a chair in regenerative medicine at QUT and the co-director for Max Planck Queensland Centre of Marine Material Science and Extracellular Matrices. Professor Hutmacher is a global leader in scaffold-guided tissue regeneration. Patient-specific scaffolds are designed and manufactured by using cutting-edge 3D printing technology platforms and then implanted. This technology has repaired leg bones and badly damaged skulls and corrected congenital deformities. Approved by US and European authorities, more than 70,000 patients have been treated worldwide. Ladies and gentlemen, your panel, and I'll leave you in the hands of Professor Jagadish. Over to you.
Okay, thank you, Veena, for that kind introduction of the panel. And so this is the last panel of the day, and today we are going to talk about creating conditions for translation, commercialization, and collaboration. This is a topic which we have been discussing for the last 30 years about the importance of commercialization of our research, and so the collaborating with industry also. And but at the same time, we seem to be not changing the dial too much. And we're always, for example, we are 13th in economy in the world. And when you go and look at the economic complexity index of the Harvard, which it brings out, we are 91 behind Laos and Kenya. That's economic complexity index is indication that how resilient our economy is. And then obviously we are not very resilient as a country. So that means we need to do a lot in terms of discussing about how do we really move towards technology-based economy, and how do we really make sure that our economy is becomes more complex than only reliant on resources or services sector, but not really reliant on the manufacturing and technologies or so. And we got an excellent panel, and then we got people, those got a lot of experience in terms of their commercialization and working sometimes, some of them are also in industry. Let me start with the questions. And what do you see as the unrealized opportunities that lie ahead of Australia in terms of areas of high research translation and commercialization potential? So I'll probably start with Wei. Wei, please go ahead.
I've been thinking more from my own experience. The first one, I think, is Australia. We are an ocean country. If you look at our land territory compared to ocean territory, the ocean territory is plus double. And we are also the third largest sort of ocean country. We have, we have a huge, not just only the ocean territory, the huge marine biodiversity, marine bioresources. And this is one of the biggest sort of unrealized opportunity for Australia to develop a globally competitive blue bioeconomy. So what does that mean? That means that we have, of course, I just do some comparison. And Australia is more or less have, in terms of marine territory, is about close to 10%, 9% of the global sort of marine territories, put into perspective. And China have 10% of the Australian marine territories. And China's marine, blue bioeconomy is about 50 times of Australia. That's Australian 2% of that. So put in perspective, we actually have utilized maybe 0.2% of what we have in our sort of marine, territory. So this is where I think Australia, in terms of a marine nation, our next generation of whales will come from ocean, and how best we can manage our ocean resources. Here I'm talking about more the regenerative, sustainable marine bioresources, not talk about mineral per se. I think we get very big opportunity, and this opportunity is driven by international demand, global market demand. I think this could be a big area we're investing. So now I'm working for the Marine Bioproducts CRC, and this is the first sort of national initiative. We bring this fragmented research capability, also the infant industry together, to try to drive our growth in the next 10 years. What we talk about in the next 10 years, we try to build a marine bioproduct industry where we call it third generation of a marine bio industry, in relation to the first generation fisheries, the second generation aquaculture. They're mainly growing the stuff for food, but we are growing the stuff other than seafood. That means functional food, nutritional products, biomaterials, marine drugs, and you can think of all these different sort of opportunity. So focus on this high value opportunity enabled by advanced manufacturing, but of course we are fully aware Australia would like a clean, green environment. So my core expertise area on the marine biorefinery is really try to develop the technology solution. We would be able to utilize 100% of the resources and have the technology which we don't generate a secondary waste product. So that is really fit into the circular economic context. So the Marine Bioproducts CRC is the first national sort of research for industry flagship or endeavor. We'll try to see the next 10 years we can build an industry at least equivalent to the current aquaculture industry, somewhere close to $1.5 billion per annum, generate about 10,000 jobs. But looking globally, I think is by 2035, it's predicted to be $760 billion in this industry sector. So Australia definitely have ample opportunity to build industry worth $10 or $100 billion in this space. So this is just one I want to see. If I can spend a little bit of time to talk about a second big area, I think we talk about research translation and commercialization. I said actually we have one of the big resources we haven't really capitalized on is our intellectual property tied with our PhD graduate and the PhD students. I was doing some research on this space. Australia currently we have about 58,000 PhD students enrolled per year, and now we have 10,000 PhD graduates every year. I look at employment. Actually 60% of those PhD graduates, which is either unemployed or employed or not really what they've been trained for position. This is a huge waste of our resources, because I calculate per PhD student, the scholarship is about $120,000 you spend over 3 or 4 years, and also your sort of other research cost probably another maybe $100,000, right? You talk about a per PhD student, not talk about supervisor time, infrastructure, at least $250,000. So that 10,000 PhD student, 60% is in the position not being utilized. You talk about is $1.5 billion per annum. If you think of this context of the university, recent government university industry, university research commercialization scheme, talk about 11 years to invest $2.6 billion. If you can really turn the 6,000 PhD graduate, translate them into the commercialization, whatever maturity, you get every year, you have that $1.5 billion put into good use of it. So this, I think, is a huge opportunity for us to move forward.
Yep, okay, thank you, Wade. And Madhu, you worked with companies small and big as well, and then what's been your perspective, and then particularly in terms of where you see as opportunities to be able to exploit in terms of translation of technologies?
Thank you, Jagdish. I'll carry on from where Wade left off, and the last point he made about PhD students and their ability to translate or be entrepreneurial. That's something which we've been waiting for a long time coming, right? And especially in STEM, like I co-lead a group of nearly 40 members. They're almost entirely migrants. And for us, it's a big challenge coming into a new country, setting up ourselves in a new culture. It's even more of a challenge, getting into a network where we learn to, become entrepreneurial in a new culture as well. I feel a lot of missed opportunities sit in that kind of space. 3 to 3.5 years of getting a PhD degree, and then you're trying to also cram in communication skills, entrepreneurial skills, every other skills which you can. A lot is being asked of academics, and I think there are genuinely a lot of PhD students who are interested in taking their entrepreneurial journey, but just don't have the skills or the networks to be able to go forward in that particular space. That's a big opportunity for me. I completely echo what Wei said in terms of we shouldn't lose out or miss out on that talent. I personally work a lot on devices which are used for healthcare and for aged care. It's been an interesting journey because I came at it a little too early maybe. We patented the tech in 2015, and Australia was not ready to have those conversations back then. 40, 50 industry conversations with different people in the world, nothing translating into funding. Starts off very optimistically, and then slowly your optimism wanes off. And then you realize you need to be flexible. Like I always joke, we work with flexible devices, and I've learned I need to be as flexible as my devices are. It's not about what I want to push out to industry, it's what the industry thinks is important, and they come out to me and seek solutions for. So almost all the things which I do now, if you'd asked me 5 years back, where do you see your tech? I certainly wouldn't have said aged care. I certainly wouldn't have said embedded in mattresses. I wouldn't have said it's much more in the healthcare space. I was looking environmental, but turns out I had to be looking inwards and not outwards. So I think for me, the biggest opportunities were emerged when I've just let go maybe a little bit of my ego and just gone with, tell me what the problem is and let's work together to get those solutions.
Okay, you make a very important point of where the opportunities are and go with them rather than really embedded, wedded to your own technology and then feel that that's the one which I'm going to do. That's wonderful. Both of you make very important points also about entrepreneurship and creating entrepreneurship culture among the younger generations so that they're thinking of translating their technologies or starting companies at some stage of their career as well. So that's an important one. Michael, you worked with companies small and big as well. What's been your experience and perspective on this particular aspect?
I'm working with companies, they're all enjoyable, challenging and frustrating at the same time. Just like dealing and speaking to everybody in this room is enjoyable, challenging and frustrating all at the same time. It is a relationship in every aspect of the word, and you never know who you're going to be speaking to and how that will evolve until you do it. And that is, I guess, part of the joy in learning who these people are, what their problems are. I quite often will say to people, I want to talk to you, I want to hear about your problems. I don't guarantee that I can help you. I don't guarantee anything, but there is a chance that I might know someone who can, or there is a chance that in 6 years you'll get a random email saying, hey, that thing that you talked to me about 6 years ago, I think I have a potential solution. And unless we are open to those opportunities, we will never be able to address them. In terms of what the big opportunities are, I see one technology-based, and we have the genome, the transcriptome, the microbiome. I think we will move to the environmentome, if that's the right word, I don't know. And that is where we are able to position the individual within the environment with a suite and multitude of real-time sensors positioned in our environment and in and on us to provide a level of information that we will not even be able to comprehend and handle. So that's my technology opportunity. The intellectual opportunity is related to the earlier conversations that there is a large proportion of our community that do not even undertake STEM in education. And if they do not do that in primary school, they do not do that in universities, they do not do PhDs, they do not translate, they are not entrepreneurs. We have a huge human resource that we don't capitalise on. And I think part of that is because we have centralised a lot of our STEM. And in the place where I grew up, there was when I grew up, there was a whole heap of manufacturing advanced technology capabilities that have since all shut down because it's cheaper to ship the natural resources to a central location to manufacture in a local place. And that has flow-on consequences for the school children, because I also last night just looked up their recent career expo, and they were talking to hairdressers, shop assistants and farmers. There was no STEM. And that's just one example, and I'm absolutely sure that is happening across the country. So I think if we want to capitalise on that opportunity, we have to think about commercialisation, translation in some more regional settings to actually have that flow on through the community, because if you cannot be what you cannot see, and if it's embedded within that culture of the community, then I think the impact will be much greater.
Okay, thank you, Michael. And you really make a very important point of really creating opportunities for the people in the regions. And people have been talking about hydrogen technologies, potentially could be in the places where the mining industry has been, and reskilling people, and also the renewable energies like battery technologies and other renewable energies as well. So make an important point. So now let's move to the next item. And of course, government programs have really come, and then many programs we have been really going through the last 30 years or so. And now currently we've got the University Research Commercialization Scheme. And and what has worked and what has not worked, and then how can we improve that one to be able to make it work better for us. Jack has got a lot of experience in this space. Maybe Jack would like to lead this discussion, please.
So I'm going to continue the theme of enjoyment, collaboration and frustration, but also the theme you've heard so far of connecting the research to the market requirements. And so the budget last night confirmed funding from a number of programs that it's worth knowing about, which is basically an adjustment to the way in which some research funding is provided inside the Australian government's programs, which turns it a little bit on its head. So previous grant programs have basically been grants for research. The grants that are being offered now by the Department of Education in the University Research Commercialisation Program are going to be administered essentially in the same way that a venture capital firm administers, that is to say, proactive management during the duration of the actual delivery of the grant outcomes. So, this is a whole new activity for the Department of Education to be building and growing. They're going to need to embed a group of commercial beings inside the department and run it basically as the equivalent really of an early stage venture capital firm. So that's going to be quite a change for the dynamic of the engagement with the university sector. Quite an opportunity for the entrepreneurial players in the university research sector to go for it. And to give you an idea of what the magnitude of that looks like, last night's budget showed that in the current financial year, there's not much expenditure, but there's $100 million expenditure expected next financial year and $160 million the year after. So there's an opportunity for projects that look like they have good commercial potential in those areas which are high priority for the country to actually be packaged up and taken into that process. I would just observe that my experience is the first round of a new granting program is a lovely moment to strike while the iron's hot. If you think about those first round CRCs, for example, gee, didn't they go brilliantly before it got all very complex. So that's the first observation. So there's a number of other programs associated with the package as well. So in addition to those university grants, there's also additional funding into Main Sequence Ventures for it to run its early stage venture capital firm that will potentially pick up some of the opportunities out of the accelerator and also other opportunities across the university system. So what you won't know is that at the moment there's about 45 companies that have been funded by Main Sequence since around 2018, something like that. They've engaged with a large number of university research groups, so it's quite a strong engagement that's going on, really not particularly obvious on the surface. So I think that's going to be an interesting change in terms of thinking about what the market requires, as opposed to this being the old standard model that you've all seen before of nice research occurs, middle cartoon, magic occurs, end outcome, everybody lives happily. This is taking that, what does it mean to live happily, back first. So the other program to mention is so that's the Education Department, delivered some of it with CSIRO's assistance, including the ON Accelerator, and there's 3 strands of industry PhD program that are going to be funded as well. And there are ARC industry fellowship schemes that are also part of that overall program. So the other one to mention is that the industry portfolio is going to deliver the National Reconstruction Fund. Once again, in a series of priority areas that are very similar to the manufacturing priorities from the last government, a few minor adjustments. Last night's budget indicated that $50 million would be purposed into that to commence the program. That's a $15 billion commitment by the government in those high priority areas. Now, is this about research commercialisation per se? No, it's not. But what is it about? It's about diversifying and transforming Australia's industry and economy to secure future prosperity. You have to work on the assumption that's going to be a lot about value add to our resources, and therefore it's a big opportunity for us when we're doing applied research to deliver new big commercial opportunities that are likely to produce resident economic value activity in Australia. So I think that's once again an initiative that's arguably of a similar sort of new initiative magnitude as the CRC program. So we're entering a new era. There'll be things we get right, there'll be things we get wrong. There'll be frustration, collaboration and excitement.
Okay, thank you, Jack. And let us hope that we'll hopefully be able to move the dial in terms of that strengthening those relationships and be able to translate the technologies and developing industries. And so now let me ask Kirsten a question, because she has worked in BHP and then now she is at CSIRO and she has a lot of experience in terms of industry research collaboration. Currently, university-industry collaboration ranking in Australia, we are ranked at number 40 in the world, whereas Israel is number 1. And growth in innovative companies, we are 28 and Israel is number 1. Entrepreneurial risk, we are ranked as 36 and Israel is number 1. Anyway, let me come back. And Kirsten, can you give us your perspective in terms of this industry research collaboration and how do we really make it better?
Yeah, thank you. So as Jagadish said, I've come from industry into research, and it's been a really interesting and eye-opening transition for me to understand what some of those real barriers are. And I think if there was one thing if I could wave a magic wand and make happen in Australia, it would be vastly more porosity between the sectors. More researchers working in industry and more industry people working in research. We often talk about it going the first way, research into industry, and that's really important because I think, as we were talking before about understanding what the market needs and wants, there's no better way to do that, really, than to embed yourself in that environment. But I also think there's opportunities to do it the other way as well. Because industry clearly not a homogenous thing, right? There's all kinds of industry. There's small, medium enterprise, there's big industry. But they don't, for the most part, it's very opaque how research works. They don't understand how to engage effectively or what the criteria are for framing a great research project or proposal. And so I think that we've got to get more clever about bringing industry in all its forms into research. CSRO operates and runs and provides some really phenomenal programs through our SME Connect program, which is a great way to connect small medium enterprise with research, with the Australian research ecosystem. And what's been great about seeing some of those success stories is just how effective it is when you get that collaboration working. But it needs structure and it needs purpose. And so I think more programs to make that more fluid would be fantastic. To add to a few of your statistics, I think, and this won't surprise anyone in the room, but only 30% of researchers are based in industry in Australia as compared to 70% in Korea, Japan, and the US. And certainly there's other statistics in Europe as well. And according to a recent report that Cyro wrote, only 14% of all companies in Australia, irrespective of industry or employment size, collaborated for the purposes of innovation. So I think my experience was that industry innovates with suppliers much more easily because all the incentives are aligned. And it's incremental innovation, it's quite easy. But I think to really get those breakthroughs, we have to work out how to make that collaboration work better between research and industry.
Good. Okay. Thank you, Kirsten. And then sometimes also the universities are blamed that universities are not working with industry. But at the same time, if you want to work with somebody, then both need to have interest in really be able to really do that one. And so I think the key point which you're making is that you need to have structures to be able to provide opportunities for both sides to really work together rather than only expecting one to really work with the other.
Absolutely.
Yeah. Thank you. So now let me go to the next item in terms of what have been the key barriers to collaboration in your domain in terms of with industry, and how do we remove those barriers? And maybe you can start, maybe Dietmar, you want to really go and just of course you worked with small and big companies, and maybe I'll ask you a question about have you seen any barriers at all, first of all, and if there are barriers, how do you remove them?
Well, I think we have heard a little bit already on the barriers. Actually, let me do the other question about, compare Australia to other countries. And you did Israel, right?
Yep.
So what are the differences? Some of them you mentioned, right? But I have a colleague at the moment in my center who is from Israel who does a sabbatical with me, right? And we had a discussion about the culture. And she told me that she thinks that Israel is a cowboy country. It is in complete disarray. And I said, what? What are you talking about, right? And she says, when you live in Israel, you think that what I'm telling you, right? But for us from the outside, I told her things like you said, right? Here it's a nation. Of course, there are conflicts and so on, but they are very entrepreneurial and so on, right? So again, my point is what you haven't mentioned, and coming back to also with the PhDs, we have to change the culture. And I'm a little bit controversial, which our MC knows about, right? We are way too comfortable here. And if we don't get out of this, we will not change. And of course, this is super difficult because we are a super rich country. I mean, I'm originally from Germany. I come back to this also, but I'm also Australian, right? And of course, I'm here because I feel also so comfortable. It is so great, right? But I think on the global base, if we don't come out of this, and if we don't train our students to get out of this, we don't get there. So sorry to put you on the spot, right? The amazing pitch, and you're right with the figures. But how do you turn this 100 PhD students?
6,000.
Well, you will have 100 in your CRC, right?
Yeah.
How do you turn all of them in entrepreneurs? I bet you at the moment, and looking back, we are doing just a study on the CRCs. It will be less than 5%. And the thing is, again, we haven't set up the culture at the moment. Universities have tried. And now we come to the barriers, right? One of the biggest barriers is, as universities, from our management, also comes in the academics, we have these amazing ideas. We develop this amazing IP. And that's why when industry picks it up, we should get at least 50% what comes out of it at the end, right? Because we are the brilliant people. If I'm in industry, right, and I'm in medical devices. In medical devices, if you're fast 10 years
you go into clinical trials and have FDA approval, right? So I started this, and I have done a spin-off company, right? If I would have gone in with the thought that I would own 51% of this company today, this company would never exist, right? So these are the barriers. So we really have to work harder on our universities, on our commercialization offices, right? So again, the other fact is when you ask, for example, MIT, right? Everybody thinks the research income from MIT has a super high percentage proportion based on royalties. You know how high it is? 2-3%. You know how big the philanthropy money is they get from the graduates? Right? So again, I think we have to shake up the system. That's my point about the barriers, right? And again, coming back to the entrepreneurship, again, very controversial comment. I think we create too many PhDs in Australia, maybe also in other countries, right? Because you mentioned the figures, right? We create these PhDs. They are not trained for entrepreneurship. They are not trained for industry. So what? They all look for jobs in academia. How do they get in jobs in academia? We grow our universities, right? So this is a cycle I think we have to break up in the future. And I stop here.
Okay, thank you, Itmar. And anybody else want to make a comment on that particular aspect of? Yeah, go ahead, Vig.
Yeah, because you challenged me in terms of the CRC, so what's our model? So when I start to prepare the CRC bid, right, I was looking to the situation while all CRC cities were industry-driven, and we try to train our PhD students for industry. Reality actually is the opposite. I was checking so how many percentage of the students are actually being employed or retained in the industry is quite small in most cases. So this is why I bring that statistic in there. I said that we really have to change the culture and also talk about creating the environment and conditions, really to see the PhD or intellectual capital, which is the enabler for the technology translation or research translation. So they need to have high percentage of those people being retained by the industry as trained for. So if the CRC can achieve 50%, it's good. 100% not possible what we expected because they're industry-driven research, right? But most of the cases have been trained given somewhere else, not really in the industry. You spend enormous amount of money and time, effort, but it just go away. Okay, that's where I think we are trying to do something different, but we haven't achieved there yet. So you talk about key barrier, come up with the first one. Really, why this is happening? Because we have misalignment and the mismatch of the industry and research expectation of impact and success. So what does this mean is our system, like academic system, we actually don't reward what industry wants. That is a fundamentally problem, maybe controversial, but you can think of. That is why those PhD students, 60% cannot get a proper job, or underpaid job, or not get a job at all. So of course, industry expected you are providing a solution rather than piece of technology. Also come to your comment. This is a long way, leading from academic discovery or development into commercialization. So therefore, we have to realize our value proposition as researcher or research organization, we're here, but it's a long way to go to commercialization. So either you say we stopped, or you are still participate in the commercialization or translation pathway, but you have to be fully aware your role. When you go to next stage, and you will be smaller and smaller. But important, your input have to be there to some degree because maybe more research questions come back, and you still have to innovate. So this is where I think this ecosystem, which not been built up yet. So we need to do something to change the environment. I think Jack, your talk about the budget, also the way of actually making some change. That's actually a good move. Very successful, I don't know. I think there's definitely more to be done in terms of both the government providing the support in the policy framework, and also important is resources. You need to have things happening there, not just only early stage of this development. It is really the huge gap in terms of commercialization. So that's probably my second barrier, is lack of a collaborative investment in terms of size, scale. So often it's quite fragmented because people don't want to collaborate as such, not just only between university and industry, and also research to research, industry to industry. So I always, in RCRC, I always thinking, because we are infant industry, it's better we come together as Australia, as a nation to compete rather than we compete internally. So this is something I think is need a cultural change or significantly, to be collaborative and to be partnership, same as this Australia sort of relation competition. So this is something I think is possibly most important. PhD addressed that KBRA because I think it's most important. You have to have the talent, the people to drive the stuff. So a lack of leadership, and including entrepreneurial sort of education and training. But more than that is you have to take off the driver position, particularly for PhD student training. So that's the leader, because only 1% of the population, over 25 years old have a PhD. So it's still a small population in the country, but if you can make best use of those intellectual capital, we will be there.
Okay, thank you, Wei. I think any of you want to make any further comments? Or okay, go ahead, Madhu. Yeah.
Just taking a different spin on this one, and it kind of goes back to Kirsten's point about the boundaries being more porous, right? Where you're constantly going between industry and academia, and your CV and the value which you bring is known and respected on both sides of that door. In some ways, I always compare it to the US, and I go, if it's so easy there, why is it so hard here? But then I think we are forgetting in the US, most industries have a research and development arm, whereas most of our industry partners here don't have an R&D facility, or they don't have an R&D arm. The collaboration with academia is where the R&D happens. They don't have a place to absorb the PhD graduates which we produce either. So as much as I would love to emulate that, I think we still have one more problem to solve before we can get there. The problem we are in right now is, if I look at it from the ECR perspective, the early career researcher perspective, they don't know where they need to be. So they're trying to, publish at the same time, they're trying to patent at the same time, they're trying to make sure they can commercialize at the same time, communicate at the same time. I feel sorry for them a lot of times. It's a very difficult situation as such. Career stability is already, shaky, and plus you're trying to be so many things which you have not been before. So, and they don't know because they don't know what the career opportunities are either. So sometimes we don't give them enough to focus on and say, just focus on this and we will value this and respect this and carry you through your career. And I think that's the problem also which we need to solve. So take even the new ARC industry fellowships, right? I mean, a lot of it is, my fear in the way it will be assessed is people assess it similar to the way they assess the other ARC schemes. But the concept and the need for this is completely different to having a DECRA or a future fellowship or a laureate. So things are changing, but I think they can't change very quickly. It's a culture which has to change along with it. But I feel the ECRs are the ones who are really facing the brunt of this right now.
Yep, thank you, Madhu. Jack, please go ahead.
So I have this image running through my mind. This question's come up to my recollection in the 80s, the 90s, after the global financial crisis, and certainly since 2019 in a more intense fashion. There's a perfectly reasonable argument that we're over-investing in research in Australia in the publicly funded sector. If you think about it from the perspective of what we get out at the other end from research commercialisation. If you sat down and you did the sums, would you invest that amount in research? That might be a horrible thing for me to say in this audience, by the way, but I'll just make the point. But the topic is creating conditions for research commercialisation. And the thing which we might be hoping for in 25 years' time, when we have this conversation again with a different set of people, is that the demand side has changed massively. And that we have an Australian economy that's producing a much larger portion of high-value products based on that word that became unpopular, innovation. And that was the outcome of the number of initiatives that are going to go over that 20 years. Because right at the moment, if anything, we're over-servicing the demand because actually the economy is too easy at the moment. A good crisis would be helpful in this regard, just to say it out loud. Not that we wish that on anybody. But right at the moment, we're trying to improve the initiatives to get the research out. but actually the most persuasive bit's going to be the demand side in terms of engagement, in terms of student engagement, and in terms of entrepreneurial stimulation, is the hypothesis I put.
Okay, I buy into this, but there's another very important factor. Again, comparing this internationally, right? Which also in the previous discussion about the STEM. If we are honest from the universities, also the head of departments and the deans, we all know that our undergraduate program, next to the funding, which in the big picture is only 20% from the ARC and HMRC, the money which goes into research comes from our undergraduate programs, right?
Yep.
Yeah, so this is a very vicious cycle, right? So, and I understand, of course, the tension. So now you want to rise up in the ranking and so on because you get more students, which means more income. So how do you rise up in the ranking? You're rising up in the rankings if you publish more in Nature, in Science, or all those things, right? And again, I think that's an aspect which some of us somehow all know, but nobody wants to disrupt it because everybody is after growth. So I think we also have to discuss this and bring this into the picture. And then coming back to Germany, right? The difference is, and you can also argue for this because there are disadvantages. In Germany, the education doesn't cost anything, right? So you don't have that cycle. But of course we have, which was in the past, you know, the one colleague mentioned, again, I wanted to mention this before with the economics, right? So now we have the students in high school, and I have an example also with one of my sons. He selected everything in science in high school. And then he did 1 or 2 years of orientation, and then he decided to study science. So he had to do 4 extra courses, right? And he had to pay for them, which I think was good for him. But again, we have to think about this cycle again when we talk about this economics, right? Which I think needs to come into the picture. And then giving one more example about Germany, also about the STEM area, right? So I'm visiting professorships in Munich and in Aachen, which are the top engineering schools, right? And you mentioned the embedding of industry. You know how many chairs in mechanical, electrical engineering and mechatronics in these top engineering universities come from industry? 50 to 60%. Do they publish in Nature? Do they publish in Science? Never, ever. Do they get millions of euros from BMW, from Siemens? Do they develop machines, turbines? Do their students go back there? Yes, right? So again, my point is we need to look also at this in Australia. And I always say, you know, there's a big difference between science and engineering, which we mix up a lot, I think, in Australia. Because the science is about the fundamentals and so on, right? But when you do engineering, you build something. You are not working on fundamental mechanisms. So if you really want to change the culture, you cannot have a PhD student, you think, who becomes an entrepreneur, which works on a fundamental problem. Yeah.
Okay, I think we've got an excellent discussion, and so you've given some models of also of various countries like Germany and Israel, and we talked about US is another place which talked about. And by the way, UK has done the review of the research sector, and they've identified that the government has gone for a full costing model to avoid this complexity of this of education trying to really subsidize research and then leading to these perverse actions by the university sector and various things which have happened, which sometimes are challenging for our country as well. So let's now go to the questions, because there are lots of questions. So Peter Kambaris. Peter Kambaris is here? Peter?
Thank you. A very great session there, and it was great to see the perspectives across the full spectrum. But I think you've actually ticked it on the shoulder there. It's about the demand side issues that we're facing. So what are the leading indicators that we should be learning for, monitoring, keeping the metrics on, to actually help push that demand side indicator through?
Who wants to take that?
I'll make a start.
Sure.
I would
Please
have
try
thought-
to keep the answer short because of the limited time we have, please. Yeah.
I think the first metric I'd look for would be business R&D expenditure. Now, I know at the moment that's a metric which will have a lot of questions around it in terms of whether or not we can rely upon the data as actually going and investing in translation of innovation, the nature of that. But that's the place, if you've got business, and in particular big business, putting its money into driving something, there'll be a reason for it. There'll be a reason for it because they can see an outcome. And if it's big business, you'll know that they've got the capacity to actually take risks on longer term stuff rather than small enterprises.
I'd love to see a metric that was something like existential crisis, or like like a burning platform metric, because I think this goes back to what you were saying about the complexity or lack thereof of the Australian economy, and the fact that so much of our structural industry does not see any need for disruptive innovation, because it's just, as you said, it's been so good for so long, and they just don't see that burning platform. So I'd love to get a really leading indicator of the industry's going to be dead in X years if we don't do something really different. So I know that's aspirational, but that's what I'd love to see.
Thank you. You need to have a crisis to really come up with some new solutions. You make a good point. And Remy, is Remy in the audience here? Please go ahead, Remy.
My name's George Mollebrow from New South Wales Division. This is a complex area, but if I could put this issue of engagement between industry and universities very simply, how should universities create a value proposition so that industry would want to fund research that's relevant to them?
That's a good question. So Germany has got, anybody wants to take that one, let me answer that one. Germany has got a program, industry PhD program, and so the student has to go and talk to somebody in industry and then find a project which industry is interested to work with the professor in the university. By having two supervisors from both the places, particularly driven by the industry, that was led to great outcomes for people in Germany. And most of the time, those PhD students end up becoming employees of those institutions as well. So that's one example which other countries people have addressed that. Thank you for the question, which is a good one. Now let's move to next question. Michael Milford. Michael Milford?
I guess this goes to the point that Madhu made about the fact that we don't have a preponderance of large industry-based R&D labs. How much of this is a chicken and egg problem, and how do we sort of grease the wheels to get it going?
I think a lot of times we consider them as lost opportunities, right? It's a bit like the electronics industry thing. For a long time it was like, no, the electronics industry boat came and went and it's gone, and that's why we won't have electronics industry again. And then everything gets banded together as electronics. A lot of things which I do don't require your semiconductor level clean rooms, but they're still called electronics. You just need a prototyping facility or a lab which can do this at much smaller quantities, or and everything does not have to be done at manufacturing scale. Maybe we prototype enough and then we give it out to the manufacturers. So I think there needs to be a lot of our research, a lot of our literature, a lot of our findings are relying on decisions which were made 20, 30 years back. I feel like the world has moved. Our innovations have moved, our research has moved, and so does everything need billions of dollars of investment, or do some of them need just smaller investments? But there's a lot of talk about sovereign manufacturing, but they have to stay sovereign, and we have to have the ability to do it here rather than have reliance elsewhere. So in some ways I feel like a scan is required, again, just to understand what are those missed opportunities, and are those opportunities coming back to us again now for us to pick it up and run with it right now.
Can I just add on to that too? I think I agree with everything you said. Australian industry is not going to suddenly come up with the R&D labs that exist in other places. I mean, it would be great if they did, but they're not going to. And so you'd expect me to say this, but this is where the role of translational science and engineering comes in, because I think that valley of death is so critical. From my experience in industry, it goes to that absorption problem. Most of industry, and I can look at one of my former colleagues as well and see if she agrees with me, but most of industry has no ability to really absorb early TRL innovation, none. They like it, it's interesting, but they can't actually apply it. They need it to be brought forward. They need that investment wherever it happens, whether it happens in universities or CSRO or somewhere else. It has to be higher. It has to be higher before they can take it in. So I think that that's incumbent on the ecosystem as well to create, a lot of it is engineering solutions sometimes, but it's making sure that it is brought to a higher level before industry can take it in.
Okay, I think we're running out of time, and our Veena is already standing up. That means then I should shut up, and that's the indication. And maybe I'll ask a last question to get the university sector DVC research is here from Callum Drummond. Would you like to ask a last question, Callum?
Actually, more of a comment than a question, Jagadish. I think we really have to be careful about not spreading too much fake news in this space. I'm not aware of any technology transfer office in universities in Australia or CSIRO that try to do unrealistic deals this year, now. It's not a contemporary view. Just look at the Commercialisation Australia annual report and see the hundreds and hundreds of licensing deals that are done by universities and CSIRO, and the hundreds and hundreds of direct research contracts that are being done between universities and CSIRO. I don't think there's too many PhDs being produced. In my university, 80% of our PhD graduates actually go into government and industry, not academia, and many other Australian universities are like that as well. That's actually a good thing, and the reason why it's good goes to the point of absorptive capacity that was mentioned earlier. The more PhDs, even if it's only one or two in SMEs that we get into industry, the more the overall absorptive capacity will be increased, and then you can have the type of conversations that you want to have with industry in terms of moving along on the innovation pathway, the pathway to impact, as many people call it. And the third thing is the environment is markedly changing in Australia at the moment in terms of pre-seed and seed investment. Historically, that's where a lot of the gap's been for universities. You can get the funding to do the discovery and curiosity based. You might get a provisional patent or an international PCT, and then you can't find the funding to move it any further. In Victoria, we're really lucky. We've got the Breakthrough Victoria Fund now, a $2 billion fund. It's actually doing a pre-seed fund with each of the individual universities, so we'll get that movement of early TRL stuff from 2 up to 3, 4, 5, and then the seed funds and the series funds will come in. So I think I'm very optimistic about the Australian ecosystem at the moment. I think there's a lot of good signals in it.
Okay, thank you, Callum, on that optimistic note, and let us close the panel discussion on this optimistic note, and thank the panel members and also all the people who participated in this.
Thank you, Jagadish.